Hello, everyone. My name is Dmitry Petrov. Today, we are going to talk about machine learning with Git and experiment tracking with Codespaces. When you create your machine learning model, you need to train the model dozens, hundreds, sometimes thousands times. And that's crucial to keep track of all the experiments you run. So you can return to the past and understand what happened yesterday, what happened last week. And that's important for your team to understand the progress of the project and how to reproduce your results. The experiment tracking toolset become a crucial part of your ML infrastructure. But you will see that even such a simple problem as experiment tracking introduce a huge overhead to your IT infrastructure, to ML operations. Today, we will learn how to simplify operations around machine learning, how to track experiments not without introducing any additional pieces of infrastructure. Instead, we will be using Git and ecosystem around Git in order to track your experiments and collaborate in the team. A little bit about myself. I am a co-founder of a startup, Iterative AI. We build tools for machine learning. We believe that machine learning engineers and researchers should live on the same ecosystem of the tool as software developer. So in this way, we can collaborate more efficient and build our IT application faster. We need to use Git, GitHub, and all the ecosystem around to improve efficiency of our teams. My experience came from Microsoft. I was a data scientist at Microsoft Bing for a number of years. And later, I created an open source tool, DVC, or data version control, which helps you to manage your data set, models in storages, at the same time, use them in your Git repositories together with your modeling code. Today, we will be talking about experiment tracking and how to use DVC for tracking your experiments and utilizing Git ecosystem. First, we will talk about experiment tracking and importance of this experience, why we need this, and how people use this to improve their efficiency. Then we will talk about your IDEs and how to get this experience without any additional pieces in your infrastructure. How to utilize VS Code, IDE, how to utilize Git to track the experiments. As a last step, we will be talking about resource orchestration, how to train your model in a cloud using GPU, how to get the best developer experience possible. And we will be talking about Codespace specifically, which put together all the pieces such as Git, VS Code, GPUs, and can give you the best developer experience while you developing your models. So, ML experiment tracking. When you train dozens and hundreds of your models, it's really complicated to remember what happened in the past. Even today morning, do you remember what metrics you got when you was training model today in the morning? Do you remember what metrics your model had yesterday or maybe a month ago? It's really complicated even for yourself. I'm not even talking about the team. So you need a system, a place when this information is stored together and you can return back to any experiment that you ran before. The system should work as a Git for software engineering, but you need a little bit more for machine learning. You need to remember your source code version, your metrics, hyperparameters, versions of your data, a lot more that you need for software development. This is when the experimentation tracking tool came from. In general, in the tools, you need a few components. First, you need to log your metrics, source code, and hyperparameters somewhere. You need to have a centralized place when your teammates can look at these metrics and hyperparameters and to make some data-driven decision based on this information. And it's crucial to have ability to reproduce the result. That's why you need experiment tracking. This is the maximum value you can get from this. To reproduce the result and be efficient, it helps you to be efficient as a team. The first experiment tracking tool, at least that I know, it's a Socket, which was released in 2014. If you are doing machine learning for a long time, you probably remember that tool. I will use this tool as a reference for functionality of experiment tracking. You can use the UI of Sacred. This is a web UI when you can see all the runs you made, like with a run ID, all the hyperparameters you use, like a learning rate, 0.003, batch size, and metrics. The metric that your model produced for this particular run, for this particular set of metrics, so you can return back to the table and see what happens today morning, yesterday, a month ago. In such a tool, you can attach more to your experiments. You can go deeper. You can understand what is inside the models. If you put some visuals, graphs like area under the curve, loss functions, all the information that helps you to make this data-driven decision. And even the first experiment tracking tool supported this functionality. You can put loss function, confusion matrix, anything that is needed to remember what happened in the past when you was working on this experiment. The success of Sacred tool and the rise of machine learning in the industry created a lot more different tools for experiment tracking, such as TensorBoard, MLflow, and some others. Majority of the tool appears in around 2018, but there's still a lot of progress in this area. Let's take a look at the architecture of this system. When you work with experiment tracking tool, you need to deal with additional part in your IT infrastructure. You need to have the centralized table somewhere when you put the information, so you and your teammate can look at it. Sometimes you just need a database and web UI on top. This is how initial version of the Sacred works, or MLflow. Some solution put the database and web UI in a form of SaaS, so you just need to have a login to the system, and then you will be able to stream your metrics, images to a SaaS, so you and your team can look and visualize to the experiment. This SaaS or service becomes an additional part of your machine learning infrastructure. And this picture becomes even more complicated when you look at cloud training experience. When you need to train in a cloud, you need another additional company that manages your cloud run, infrastructure provisioning, and such. So the system becomes very complicated. You just need to track experiment. You just need to run in the cloud. At the same time, you already got 2 additional companies to your infrastructure. You double or even triple complexity of ML operations. And the question we are asking today, can we simplify this experience? Can we remove the moving parts in your IT infrastructure? How to do that? We need to reuse the infrastructure company that we already have. I'm talking about your Git as a source control tracking tool. I'm talking about your Git servers, such as GitHub, VS Code extension, your IDE. Why do you need a separate UI and service for experiment tracking? Why don't you have this experience right in your IDE, in the place when you manage your code? You won't need to switch back and forth between your development experience when you write the modeling code and your ML tracking experience when you see your runs. This can dramatically improve our efficiency around infrastructure and efficiency in our workflow. This is how we structure our next steps. We will talk about each of these components and how to use this in your ML training process. As a result, we are getting rid of some part of your ML infrastructure and using the existing infrastructure that you already have instead. And Git becomes a single source of truth for your ML experiments, for all your operations around machine learning. Let's take a look how it works. We are starting with experiment tracking user interface. How we can get the rich interface right in your IDE together with your code. So you will have your coding experience, the best developer experience you can get, and at the same time, you will track experiments right on the same application. Whenever it's run in your laptop or in a cloud, you should have those pieces together. And when you run it in your IDE, you don't need additional infrastructure. You don't need additional server because you have one. All right, now this fun stuff begins. I'm open my VS Code extension in my laptop. We start locally, and then we go to cloud. This is a regular VS Code experience. You're probably familiar with this very well. My training code, I train something, I save my model. So very usual modeling stuff. What is special about my environment in VS Code? I have a plugin installed for experiment tracking. So we can see the list of our experiments. With metrics, you can look at average precision, AUC, and hyperparameters. So far we got only 4 of those. In real case, yes, you might have dozens of metrics and hyperparameters, but let's make it simple for the demo. You can see the entire history of my experiments, and now we can run a new one. I am choosing an experiment and run it. So in this case, I will be changing the number of estimators and maximum features. Right now, I'm using a very simple project. It's an NLP problem with a binary classifier using traditional machine learning. So the training takes only a few seconds, and we will see the result soon. Here it is. A new experiment in the table. You can see the time, the new value of the metrics, and now we can compare the experiments. The current experiment performs slightly better than experiments we started originally from. This bigram experiment is actually a Git branch, the original branch we started from. And the difference, as you can see, substantial. We can go deeper and look at the metrics and graphs that we produced during the experiment. So that's this precision recall curve. You can see that our experiment performing slightly better than the original one. In addition to basic metrics, you can see more advanced visuals, such as confusion matrix for our binary classifier. You can take a look at the feature importance graph and compare those two. You can notice that feature importance is just regular image file, regular PNG file that we produced as a result of our experiments. And the tool can pick it up and show it right here. Sometimes 2 experiments is not enough. Why don't we take a look at the experiment that we ran, let's say, a month ago, and look at all 3 experiments. So all 3 are here. You can see the IDs and all the 3 graphs in one. In confusion matrix, of course, you cannot put one matrix over the others, so you can see them separately. And the same for the feature importance. This is the graph for the experiments we run, and those 2 are old ones. What you see here is a regular way of tracking machine learning experiments. But we have all this experience right in your IDE. Next to the code, you can click and jump to your source code right away. Modify the code, and after modification, just click run, and it will train and preserve all the results, all the changes in source code, all the changes in hyperparameters, and produce the metrics in the table. This is the way we integrate your development experience with your modeling experience. You don't want to switch back and forth between the IDE and coding and some SAS and some UI in a separate place. You have everything here. How we generated the metrics, how we generated the visuals. You need to instrument your source code using some libraries. In this case, we are using DVC Live library, but any experiment tracking tool has its own. You import the library and log the metrics, like here. This is I log curve. This is how I log my precision recall curve. This is how I save my precision numbers. And after this, you will see the result in the table. Before we jump to the details and see how it works under the hood, how we use Git to save the table, I want to mention to some small details here. How you can customize your table. You can remove some of your columns that you don't need anymore, some of the hyperparameters that you don't need. When the table is customized, you can understand your metrics better, help you make data-driven decision faster. But how to get this experience? That's very simple. You see the DVC plugin installed in the VS Code, and this is what you need to get the table. You can go to the extension marketplace, search for DVC, and install it. After the first run, you will see the table, and you can start your journey in experiment tracking with VS Code. Now we go a little bit deeper. We will see how this works under the hood, how experiment tracking is implemented using Git, how Git becomes the source of truth for thousands of your experiments that run. You are using the same set of tools and technologies for both, for your source code tracking and ML experiment tracking. Using Git for machine learning experiment tracking simplify your workflow. We will show you how to use Git branches, pull requests to collaborate with teammates on machine learning experiments, and how to do this efficiently using the tool that you already have. And what is even more interesting, it helps you collaborate better with not machine learning teams. Your DevOps, your IT infrastructure people, your software engineers know very well how to use Git. You already know how to install the extension and how to see the table with your experiments, visuals, and all the information that you might need. Now we will see how this is implemented and how we leverage Git to keep information about our experiment. If you look to the table, you can notice the IDs of the experiment. Believe it or not, those IDs are Git commits. And by these IDs, you can find the exact information about your experiments, the exact source code, metrics, and data, or at least pointers to the data sets. Let's do a simple experiment. So there are two different commits, the last experiment and the previous one. What we can do a simple git diff command for one of those experiments, the ID, and another experiment. Let's look at the changes in source code. So a regular git diff shows you what we changed in our source code. Now you have a proper history of your experiments with the source code changes. You can look at the difference in your metrics. So that's the metrics file we use and the difference. You can see that that's a simple JSON file with the numbers, and Git can show you the difference between the JSON files. If you're not happy with the JSON diff, right, for the numbers, it's kind of probably not the best experience. You can use DVC functionality to get difference between the numbers. So DVC diff works the same way, pretty much, as a Git does, but it shows you data-driven diff based on the metrics. In the last session, we will be talking about training in cloud. In many ML projects, you need cloud compute. Sometimes you just need a GPU instance to run your deep learning model. Sometimes you need a little bit more memory. And that's a constant source of a pain problem for teams. You need to learn how to get these resources from the cloud. You need to set them up. You need to clone your repositories. You need to sync the data. You need to, etc., 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 and not forget to shut down the instance when training is ready. So you won't be wasting money until your instance is running over the weekend. A new project, Codespaces, unifies this experience. With Codespaces, you can get your compute right from web UI of GitHub. You will get your GPU instance, your IDE installed, your Git repository cloned there. Good portion of problems that you have will be solved by a single click. In addition to all the benefits of using compute in such a simple way, we will talk about Dockerization and unification of your infrastructure. With Codespaces and VS Code, there is a way how to unify your environment on your laptop and in a cloud. So you'll have the same set of libraries, the same versions, and the same source code. It simplifies the way how you operate, especially for the teams. We will also talk about environments, how to unify environments in your laptop in a cloud and in the cloud, so you won't have this problem like, oh, it worked on my machine, but no one else, right? And Codespaces has a special technology to simplify this process and improve this experience. Let's jump to the GPU part, the cool part. This is an easy way to run your ML training in a cloud. For this demo, for GPU demo, I will be using a different project, a deep learning project. So in the web page of the project, we just need to get to the Codespaces. But for GPU, we need to configure the page a little bit. So we are choosing the GPU instance. When you push the button, it will create a container. It might take a minute or two. So instead of waiting, I will return back and launch a container that I already have. Let me click here, and we will get our server with a GPU in a couple of seconds. So that's our source code, and the source code in a cloud. And we can see the great developer experience with VS Code while it runs in the cloud. Do we have GPU? Let's check it out. There is Tesla V100. Not bad for our project. So let's start training. DVC plugin is set up. We can go to the experimentation table. And from the table, let's pick that experiment and run it with slightly different set of hyperparameters. So we are choosing this one and that one. Until this is running, we will check our source code and how deep learning project is instrumented by metrics. As before, we use DVC Live library in Python. You can find our callback function. Callback helps you to simplify the way how you output your metrics. That's an example of reporting a single metrics. This is how you log your loss function. All right, training is in progress. Let's take a look at the table. This is a similar table that you have seen before. We just use a different set of metrics, right, and different set of hyperparameters. What is special about deep learning? Usually it is slow, right? And you can look at the progress of the training in our plots. If you choose the experiment that we are running right now, you can see the progress over time. This number is increasing, and in real time you see the value of your loss function, of your accuracy. So let's look at the metrics that we use for this particular project. So accuracy, and in addition to the metrics, we got misclassified images. So that image was classified in a wrong class. So it's a croissant, which model recognizes a cat. So that's a way how you can attach more visuals to your project, and you can make a better decision about your next steps in the modeling process. GPU that you have right in the GitHub brings you like completely new experience, right? You have all the experimentation tools in a one place. But there is one more important component that we should talk about. It's about containers. It's about the way how you unify your environment. You're probably familiar with the Docker, but in Codespaces, there is another way of creating a Docker, and I would say even a simpler way of creating Docker. Take a look at this dev container JSON file. It has a reference to initial container that we need, which we use Python 3. We use a few features. We use CUDA, and we use iterative DVC. If you create this image with that features, so you will get all this functionality in your Docker container on your development environment in a cloud. You can specify more items here, like extensions, right? We use Python extension from Microsoft. We use Red Hat, YAML extension from Red Hat to visualize our files, and iterative DVC extension for the experimentation table that we have seen before. All in one place. When you ask for a GPU instance, you will get all this environment. So it helps you to unify environment for your team members. But what makes this really cool is local experience. You can use the same container in your local VS Code. Let me show you how it works. If you open your VS Code, and if you open this project in your laptop in VS Code, so it will ask you automatically, do you need to use this container? We answer yes, and we got the same container, the same environment with the same set of libraries, plugins, and all these features in our local environment. So now we have unified environment everywhere, in a cloud, in your laptop. All the code you create, all the experiments you run, work everywhere now. It doesn't mean I got GPU on my machine, so it might be running for days, but you got the point. This is the way how you can unify your environment. This is the way how you efficiently can collaborate with your teammates, with your DevOps team who is responsible for deploying your models. They will know exactly what library you use, what images you use. For business, it helps maximizing value from investment that you already made. Investment to your Git ecosystem and tools, to agile process, and to your team collaboration. So all together, we can be more efficient in creating our AI projects. Thank you for your attention. Please reach out to me to discuss these ideas.